It's 1 week from now.
Alright, so when we start in study? I just saw the print out the PowerPoints.
Yeah, definitely need it.
Okay, let's continue our study on chapter 13, inventory management. Last class, last Friday, we have discussed the safe stock model. Okay, that is D alpha DLT. This represents safe stock, right? And plus the expected demand during lead time. That will tell us the reorder point. So the safe stock model is widely used in industry. It's widely used. But the example, you guys didn't feel so hard to solve this example because what we have discussed, everything is given here, like standard deviation, and then what is the normal distribution, the mean, a lead time, everything is given, optimal service level. But in reality, that's when I was a consultant, we spent a tremendous time to figure out what is sigma DLT, what is optimal service level corresponding to D. This part is easy, expect demand during lead time, but we spend a lot of time to figure out that. And it is not easy, but this is a general idea how most Fortune 500 companies handle inventory management to determine the reorder point by formula similar to this, not EOQ or EPQ. So I want you guys get the idea of what's happened for companies. So generally, reorder points is like this, right? So we have the demand follow normal distribution, right? Demand follow normal distribution. And then we know that, okay, that's very, very little chance demand is extremely high. We don't want to count 100% service level because it's too expensive. If we hold like 10 million units, that's we have 100% service level, but it's too expensive. So we first need to calculate what is your optimal service level. Usually it's calculated if the single period model, Newsboy model, we know, right? It's CS divided by CS plus C. That's the optimal. But generally speaking, it's hard. What company did that is that A, B, C classification, right? A items, higher service level. B items, medium service level. C items, not so important, low service level. But once you get this target service level, then you determine the reorder point based on this normal distribution of demand during the lead time. You calculate the standard deviation, something like that. So that is your reorder point. Okay, the safe stock is this part. From the expected demand during lead time, so it's a mean of this normal distribution, until this critical Z value. That's the safe stock. If the demand has no variance, so that means the normal distribution shrink until this point. That's the reorder point. It's the EOQ model, right? That's no surprising. We only order the expected demand during the lead time. But since there's a variance for the demand for lead time, so that's the reason we did a safe stock beyond the expected demand during the lead time. Clear? Why we need a safe stock? Because if you just hold this one, your service level is 50%, right? Because it's only covered half of the probability. So you have to add something, it's called a safe stock, to make sure, for example, you reach 90% service level. Otherwise, you say, oh, I will hold only the expected demand during the time. So half and half chance. Half chance you satisfy all the order, half chance customer will be disappointed. So reorder points when the demand is uncertain. Well, here's the formula. But that means the lead time. We know the lead time is fixed. Then reorder points is given in this formula. Okay. So this formula is another formula, a specific formula to calculate the safe stock in this way. But generally speaking, safe stock is calculated in this formula, Z alpha DLT, which is hard in fact, sigma R DLT. Right? Here, if we know lead time is fixed, for example, lead time is 2 days, right? nothing changed. The only variable is the demand. Demand fluctuates a lot. And then how do you calculate the reorder points and also the safe zone? It's that way. Z is again the number of standard deviation. How do you determine Z? Anybody remember? How do you determine the number of standard deviation? Which inputs will lead to determine Z?
The appendix D in the table.
Appendix, yes, that's a tool. But what's with your manager? They have to tell you what, then will determine Z. The service level, right? The service level. Well, Z is corresponding to a service level, 95 percentile. You go to the appendix, you find what is Z value corresponding 95 percentile? The 85 percentile. Then go to the table to see what is Z value corresponding 85 percentile. Okay, that's determined by service level. D bar is average demand per period, like every day, every week, right? Because if lead time is by day, that's D bar is the daily average demand. Sigma D is the standard deviation of demand per period, right? Same time units as D bar. If the D bar we say daily demand, then sigma D is standard deviation of demand per day. Be very careful to keep the consistency of units of measurement, because sometimes some people have trouble. They say, okay, our demand is weekly, then the calculate standard deviation of demand per day. If you plug in that formula, that's wrong. You get wrong results. So if everything measured by day, that's good. Lead time is by day, D bar is by day, standard deviation is by day, that's good. Or everything measured by weeks is also good. Right? Lead time is weeks, D bar is weeks, and also sigma D is about the demand per week. Lead time, okay, is fixed, same time units. Okay. So you can see here, the general formula of reorder point is called sigma DLT. So it's the standard deviation of the demand during the lead time. So standard deviation of the demand during the lead time. So that's the general, which is hard. In fact, I can tell you it's very, very hard to estimate. But in this example, it's kind of easy because lead time is fixed. So we can use this formula. Square root of lead time multiply the standard deviation of demand like per day. Then it's become kind of easy. That's reorder point. Another scenario is also easier than the general formula. If we know, bless you, lead time is a variable, but demand is a fixed value. Okay. So like say daily demand is constant, 10 units per day. Again, Z, we find the service level, we find the Z. Demand is like per day, per week. Sigma LT now is the standard deviation of lead time. Okay, for example, usually you receive your item in 7 days, right? Yeah, but that's a range, right, from 5 to 9 days. If that's follow normal distribution or like uniform distribution, then you can calculate standard deviation of your lead time. You know, average 7 days, but they have some, right, variation. Right? So that's how we get the standard deviation of lead time. Again, those numbers in reality, you have to figure out that. How do you figure out? Use the historical data, right? You place order so many times from this supplier, and then you have the record, how many days you wait until you get the order, then you can calculate the standard deviation. You know how to do that, right? By statistics. Calculate standard deviation of the lead time. Okay, LT bar, which is the average lead time. Average lead time, like the example I have just mentioned, is like 7 days, right? 5 to 9 days is the lead, 7 days is the average. Here, if only lead time is the variable, sigma DLT is also kind of easy to estimate. Is the D, it's a fixed value now, demand rates per day, right? Times sigma LT, the standard deviation of lead time. Okay. That is easier than the estimation of sigma DLT. So we get the reorder point. Okay, then we have covered the safe zone and the reorder point. Next topic we'll discuss is how much to order. There, we have discussed all different models like EOQ, EPQ, quantity discounts, like or reorder points, safe stock. All this model tell us the reorder points is the instruction of our ordering activities. That okay, I don't care you order on Monday or Sunday, which we care is the quantity, place order, trigger action to place order. We check our on-hand inventory. When the on-hand inventory say 100, we place order. It can be Sunday evening, it can be Tuesday morning, it doesn't matter. Right? Once our inventory level hits this level, we know we have to reorder. That's all the models we have introduced so far. Right? But there's another type of ordering model, it's called fixed order interval model, which means it doesn't care too much of your on-hand inventory level. It's changed, right? But it has a fixed interval, which means you, for example, every Monday morning, you place order. So this interval is, what is the length of its interval? Every Monday morning you place order. What is the length of this order interval? Every Monday morning. 7 days, 1 week, right? So that's the interval, right? So we will discuss the reason for using the fixed order interval. Why we want to discuss the reason? Because scientifically speaking, this is not optimal. Or the optimal solution or the better solution should be the models we have introduced so far, which means you have to check your on-hand inventory level. No matter when this happens, like midnight of Sunday, then your system should automatically trigger the order activities. Well, that's scientific way, right? Because we have spent a lot of time, right? But why companies still use the fixed interval? We know the drawback of fixed interval, right? For example, every Monday order, if you have stock outs on Friday already, you need to wait 2 days to reorder again. Does this make sense? Not really, right? Why would you want to discard? You know for sure your Fridays, you already have problem, right? Even that you place order on Monday morning, still probably need to wait for 2 days for the order to come. But on Friday, you already have a stock outs. You didn't do anything. You wait until next Monday to place order. Do you think it's optimal? No. Not at all, right? So that drawback is pretty obvious compared to the reorder points, right? Compared to reorder points, you can place order anytime once your quantity reach these points on hand inventory. But why is still used widely? Some reason, supply policy. When I say, okay, I only ship on Monday, you can place order on Friday or even Tuesday, doesn't matter. You wait until next Monday. Well, they have bargaining power, or they are like a dinosaur supplier so many years. They have their policy. Right? You can change the supplier if you can, but well, if you go to like the raw material, right? They have this very strict policy. Grouping orders from same supplier can produce saving in shipping costs. Basically speaking, you enjoying the lower shipping costs if you place order say on Monday or early the month. You place the order on Friday, they have like weekend shipping, they charge you a higher price. So that's the reason. Or even Friday you have stock out, you want to wait, right? Sometimes. Some situations do not lend themselves to continuous monitored inventory position. That means you don't know your on-hand inventory position. You are doing a very traditional store, like my parents, they have their bookstore. Well, once per time, I'm not sure what's the frequent, but maybe once per month, my dad will go to the warehouse to check how many books they have, right, on hand. So that's before he check, he has roughly idea how many books they have. But it's not accurate. So if you have small business, it may be true, right? You don't know your exact level. And then it's easy. Okay, every Monday you place order. Okay. So for these models, compared to the reorder points, I want to ask you, especially in US, companies in US, which model is used more frequent? Is that reorder points? That means you check your on-hand inventory to place order, or fixed order interval model. In US, which one do you think we use more frequent?
The reorder point?
Reorder points? Rin say that? Agree? Yeah. Well, like US, we use more scientific method to manage our inventory. Yes, The reorder points model used more frequently in US. Well, but still, again, we have talked about like the upstream of the supply chain or small business, they still have used the fixed order interval model. But in the developing country, well, we see more companies use fixed order interval. There's some benefits here, but a lot of constraints. For example, the third one. Well, in developing country, many companies, they don't have the system to track the inventory. Well, you can't imagine. For example, I have a relative. Well, she's my cousin. She married a billionaire. At least close to billionaire. At least like $100 million assets. That's family. They just immigrated to Vancouver, Canada recently. So their family is a family focused on rice or rice-related products in China, right? Their family is so big now that their business, but it begins from his parents. So my cousin's husband's parents, 30 years ago, begin the family business from nowhere. Well, with the developments now, it's like a billion value company. But it's very interesting. Ask my cousin's husband. Do your parents have, or your company has any system to track your inventory? He told me no. And he admits they should have, because this guy gets a master's degree from the university in Vancouver, so he definitely understands MBA degree. Okay, that's very important. But it's hard for him to persuade his parents, say, okay, you need to have, because parents will tell, we are very successful in the past 30 years. We don't have this digital device or digital system. We are very successful, we focus on rice. But you understand, well, when your business grow on this level, finally you need some system to track inventory. Right? You can't just on count or monitor. That's not enough. It's not accurate. But you can think about it. For developing country, there's several reasons. First, the business scale can be small. Second, even it's a big company like this one, it's definitely not a small company, middle-sized company. But since they develop so fast, they don't have this history to build a habit to use the digital system. So that's why if you work with some international company, we have to understand why you can't track your inventory level, why you want to use this one. Maybe there's habits, maybe there's constraints here. Okay. So that's the reorder point. It's very interesting. My cousin, she immigrated to Vancouver. I think they bought a house here. Very expensive. You know Vancouver's house price is most expensive in Canada. It's probably the only place can compare to Vancouver's housing price is like San Francisco area, right, or Manhattan. I believe the area they live is like every house is about $1 million. And I say what you guys are just, right? You guys don't need to do anything. And she told me, hey, we are just normal middle class family. Okay, if you define that's middle class, well, I think we most of us are really poor, right? Well, if you live in this community, you are not middle class. That's all. That's the end of discussion, right? But anyway, yeah, she's my cousin, so I don't want to say too harsh to her. So fixed quantity model. So versus fixed interval. Well, another model we haven't discussed is the fixed quantity model. Well, in the EOQ model, we use fixed quantity. We order the same quantity every time, right? So it can be something like that. But the fixed quantity model has a problem is that sometimes you have to use your safe stock because you use the fixed quantity and order again. Sometimes you have more than enough, but you still order the same amount. It's not optimal. Again, compared to the reorder point model, it's not optimal. For example, this one. You still have a large 100 inventory. Why you still want to order the same quantity like 100 units? It doesn't make too much sense, right? You should order up to some level. The reason fixed quantity model is also used is, again, we have discussed, similar to the fixed interval model. The constraint, for example, the supplier say, okay, I only send you by batch, right? 100 units, 200 units. You can't tell me I want 125. I can't handle packaging or shipments. So you have to order the same quantity. Even you say, okay, 100 is not optimal. I only want 75, but you can't, right? Some other reason it can be also that your problem, right? Your transportation, your inventory problem. You can only order some integer, okay, batch size. Fixed interval, on the other hand, okay, even you have very low inventory level, you wait until Monday to place order again. Again, both fixed quantity and fixed interval are not optimal. If you heard this fix, why we should fix? Why we should have fixed order quantity? Why we should have the fixed order interval? It's not optimal, but again, sometimes we have to use them. Right? Okay. Fixed order interval model, which calculated in this very complex formula. Expect demand during the protection interval, which is order interval plus lead time, plus safe stock is calculated this way, minus your unhandled inventory as reorder points. Well, I don't require you guys to understand this model. It's very, very complex, right? But I hope, okay, we introduce this model for you. So in the future, in your job, if you need that model, you can refer to the formula we introduced here. Okay. That's my expectation. So, quick review on how many models we have go through on this chapter. Right? What is the first model we studied in this chapter? Anybody remember? First, very basic model. EOQ model, very good, Alan. Then, what is the next model we have studied? EPQ. What does EPQ mean, Joseph? Do you still remember? Production quantity, very good. That's for manufacturer, right? Ordering is not the most important thing, but production. Okay, what is the next model we have studied? Or any model you remember after EOQ and EPQ? That's no, before that.
The optimal stock level?
Have we discussed something happened in Fifth Avenue in Manhattan? Which person stand on that street every day?
Newsboy.
Newsboy, right? Single period model. Newsboy model, right? The third one. The fourth one, what is the model? We order a lot, we enjoy something. We increase order quantity, then what's happened? Quantity discounts, very good, Kayla. Okay, the fourth model, quantity discount. And later, we went to the big family of the reorder points model or safe stock model. Well, there's different situation. Well, one is that the demand is fixed, the lead time has the uncertainty. Or the lead time is fixed, the demand has uncertainty. Or both the demand and lead time has uncertainty. That's same model already. Then we discuss fixed interval model. You order every Monday. Right? That's the formula to calculate, right, your amount to order for fixed interval. And we also discuss a little bit fixed order quantity model. About 9 models we have discussed. So do you think this chapter can compete with chapter 3 on the champion of this class? Probably we can, right? Similar. So we do spend a lot of time on this chapter. Okay. I think we have finished all the parts of this chapter. You can read about the strategy. You know that this is important, right? For the exam, I want to remind you, the exam will cover the 3 chapters. Which 3 chapters will be covering the exam? Exam 2. 8, 10, and 13. Okay. 8, 10, and 13. Among these 3 chapters, which chapter do you think you should post a high priority to prepare the exam?
Chapter 13?
Yes. Well, obviously, why we spend such numerous time on this chapter? 9 models, it's not easy. Oh, again, okay, I can tell you in advance, most likely you won't see something like this in your exam. This one, or even these 2. Most likely, you won't see. Or except some students send me alcohol when I prepare the exam, so it can happen. Well, anything can happen. Well, in fact, last 2 semesters, really 2 students send me alcohol. Well, but it's after the final exam. I told them, okay, I warned them. I said, if you want to give me a present, wait until the final exam. Because if I made anything wrong, you guys suffer, right? So they give me alcohol like whiskey, small bottle. So I went to the cafe in the lunchtime. I bought this whiskey. I drink a little bit, and then the person that comes, you can't drink alcohol in cafe. I didn't know that. Because I'm not a person drinker. I don't know the law or regulation. Because usually I never drink alcohol. I just want to try. As a cafe, so you want to hide it. Otherwise, we have to collect it. You know this regulation? You guys know that? Everybody knows that. It's just me, right? Because for me, it's like I never drink alcohol. Not even at my home, right? Except some guests come, they bring some alcohol. So for me, I never purchase by myself. I'm not a person. But this student give to me.
Yeah, well, most people put in their coffee, like that's how they get away.
Really? Well, that's sneaky, right? I should have. I'm not a coffee person. I put on my tea. But I don't know the taste. Right? Tea with alcohol. What's it like? Right? So it won't taste very well. But anyway, good to know that. Okay, I won't make mistake in the future. I think it's just alcohol. It's same as soda, right? I just drink. I never get drunk, frankly speaking. So that's probably why I didn't know that. But if I get drunk, that's a problem. So you don't worry too much about these complex formulas. But something will ask why you want to spend so much time, right? So today and the last Friday on this complex model, safe stock, these models. The reason is again I want to remind you guys. The reason you come to UNC Pembroke, the reason you come to school business, the reason you want to get bachelor degree, maybe is that you just need the degree for some jobs, but most likely you need the knowledge and skill. Agree with me? Not just a degree, right? The degree, for example, Charles has a PhD degree. I can tell you this degree has nothing after 10 years later. Maybe now it still have something. But 10, 20 years later, who cares? If you never studied in the past 20 years, you may graduate from Harvard PhD, but your knowledge is not up to date. Right? Well, nowadays. So that's the reason in chapter 3, in this chapter, for example, in this chapter, I cover every single model to you guys. And I tell you some model I won't test because I understand. Okay, so when I taught in Purdue, come to here, one thing is the same. The contents I taught in class. When I taught in Purdue, I taught the same contents I taught in UNC Pembroke. But the difference is that I still adjust for the student because student group are different. We can't say Purdue is better or this is not as good as Purdue, but they're different. So what I did is I covered the same contents, but for the exam difficult level, I personally think here I have set a little bit lower exam difficult level compared to Purdue. That's my strategy, right? I don't want to give you a hard time. I give you tremendous amounts of difficult content and then you can't pass this class. That's not my purpose. But I will feel guilty if I cover less content than I was teaching Purdue. Because why I feel guilty if I teach less? Why?
No less.
Huh?
We know less.
You know less. You know less. Why I should feel guilty? Because later, when you compete with people from all over the world, at least different schools in North Carolina or in the nation, your employee, they don't care where you're from, right? They care, okay, do you know that? Can you solve this problem? You need to know the knowledge. Even that you are not so familiar now, but you get the idea. Later, you can pick it up so quickly. So that's my purpose. I think I will use this philosophy no matter which school I will teach in the future, right? The content level, because it's globalization. I feel really guilty. Some faculty choose, okay, our students just want to pass this class, so give them easy time, only cover like half of the content. Dismiss all difficulties. Well, I think students enjoy it, but what's lacks? You guys go to the markets, it's really tough nowadays. It's really, really tough, especially for the high level position. As I told you guys, right, I was a consultant before joining UNC Pembroke. My company only have 100 employees, only a little bit more than 100 employees. Okay, almost half of employees are PhD, and the rest a lot of have MBA degree from top university, like University of Pennsylvania, Carnegie Mellon, Duke University, University of Minnesota. Several other folks have master degree in industrial engineering. I only have like a handful of colleagues, they only have bachelor degree. But they also from very good schools, have tremendous working experience. Okay. That is. Well, even that, I can tell you, I have very close relationship with my previous colleagues, even after I leave the company for 5 years. Well, the average salary is, probably for you guys is very high. It's $100,000, something like that. 6 figures for the average salary. But the thing about the people get this salary, this group of people, half of them has PhD degree. So I can tell you, for this industry nowadays, the competition is very fierce. If you want to get 6 figures, you work very hard. You have to know a lot, get the experience, get the knowledge and skill to get that. But definitely you guys shouldn't just stay on 6 figures. I believe some of you will earn much more than 6 figures in the future. You definitely have this potential. But when the beginning stage, you want to approach this level. I'm not sure what is your expected salary after 5 or 10 years later. Is that 6 figures? Is that your expectation after 5, 10 years later? Maybe $80,000, something like that, right? You have these targets. I can tell you, it is not easy. Well, it's reachable, but it's not easy. So I want you guys have all the weapons ready for my class, at least for my field, to compete with others. That's the battlefield in the future for you guys. Not easy, but I think you guys have enough weapons to compete with others. Well, one thing the girls can do, or even boys can do, like my cousin, right? She has good degree, top master degree from top university in China, but she become a housewife because her husband doesn't need her to work, right? At all, right? But that's where I teach with my cousin. That's your choice is lots of option for me as a man. Why I can't like attract some very rich lady. There's no way I can do that. So that's anyway. And also I discussed with my wife and say, okay, tell you, honey, if you are very rich, your family is very rich, I won't marry you. Because I can't take this pressure. If I'm a poor, right, compared to them, I'm a poor person, and marry $10 million families, that's a lot of pressure. As a man, I don't think I can handle that. I don't want to do that. So there's lots of choice for us, right? For men, most men, right? So then we have to work hard. That's the reason. But even for girls, I think you also need to work hard nowadays. Right? Okay, question, comments? Finish chapter 13? No? Nothing? Okay. You know that after a hard chapter, usually we'll go to a kind of easy chapter. Or chapter 15 is very important first, but I can tell you, most likely you guys have no problem to understand the contents of this chapter. Supply chain management. So, the new objectives we have. What is the supply chain? What is logistics? Key factor of supply chain management. Current trend in supply chain. Benefits of outsourcing. Supply chain risk. Complexity to global supply chain. Ethical issues in supply chain. 3 concepts of small business to supply chain. Procurement. Supply management. Logistics. Return management. All this stuff. But I can tell you all of this, we're going to go too deep, so very little math. But there's a lot of content for this supply chain management. At the beginning of this class, hope you guys still remember, we have talked about the C-level position in the company, right? What is the highest level position in the company typically? CEO. And then what's other C-level position we learn? CFO, Chief Finance Office. CSO?
Well, I was gonna say.
CSCO. That's Chief Supply Chain Officer. Well, Joseph already go to my point, right? I just want to list all traditional C-level position. Then now many companies have the new position called CSCO, right? Chief Supply Chain Officer. Well, COO, that's our cost operation management. Supply chain is a subset of operation management. That's why it's show up here. But one company has the individual position on C-level to C-level called the Chief Supply Chain Office. Then you can understand this is become more and more important. That means COO, the Chief Operations Office, can't handle this one. There's too many work. Right? So that's why we want to create different departments, individual person, just to focus on supply chain. There are lots of job opportunities in supply chain, a lot. Let's do a quick research. Okay. So which websites you use for the job hunting, you guys? Anybody can tell me?
Indeed.
Yeah. That's I use. That's Charlotte. Okay, that's the biggest city in North Carolina. Nope. That's Charlotte. 900 jobs related to supply chain. I say Raleigh. 432 jobs. There's a lot of jobs. So even nowadays, you go to Indeed, you just look. I just want to. If you can relocate to any place in North Carolina, in South Carolina, that's several thousand jobs available related to supply chain. Well, definitely, you want to. You after finishing this class, I want you to have some knowledge or jargon or anything. That's when you have interview to the job related to supply chain. You know that, right? What we need to do. So in the UNC Pembroke, for example, your tutor, Michael Smith, he wants to pursue the MBA degree in our university later after he graduates at the end of the year. Right? And hopefully he likes my class. That's the reason he wants to pursue the supply chain management concentration in our MBA program. I proposed this concentration 3 years ago. So we had this supply chain management concentration in our MBA program. So in the current curriculum of our supply chain concentration, we only require students to take operations management, supply chain management, and ITM, like system management, and one elective class. I want to change the curriculum. We want to change the curriculum to enhance the supply chain concentration. So beyond operation and supply chain course, that's 2 courses. We know that. And then 2 new courses we propose. We are still waiting for the approval for the university and also for the School of Business. One is called logistics management. In fact, the full name is transportation and logistic management. You can see here, we mentioned that here in this chapter. Second course is called procurement and global sourcing. For the reason we want to propose these 2 classes in the MBA level is that we feel, okay, for example, in the undergraduate level, we only have 1 class, operation management. We do have the elective class, supply chain management. I was supposed to teach that class in the supply chain field, but I never have the chance to teach that class. You know why? You guys know why? Why I never taught this class?
Not enough people.
Yes, capacity. We don't have enough faculty. So they say, Charles, okay, I can't let you do the luxury job to teach your elective class. So I never be able to open this class to any students. I really want. So, but anyway, we have this class, everybody come here. But this is not enough. You think about for the supply chain. We have to discuss a little bit, but do we really discuss transportation logistics management in this class? No. Have we really go deep on the procurement and the global sourcing? No, we'll discuss a little bit here, but that is like 1 semester content. So you can see that supply chain now become more and more complex. Right? Even we have a special field. That's the reason it's become more and more important. Supply chain, by definition, is a sequence of organizations, facilities, functions, activities involved in producing and delivering a product or service. Well, logistics is the part of supply chain involved with the forward and the reverse flow goods, service, cash, and information. So if we use the mathematical sets theory about the concepts we have learned so far, so it's the big circle is operations management. And inside of operation management, that's a supply chain management. On the inside of supply chain management, there's a small subset called logistics management. Okay, so this can be an interview question. Okay, if you interview some company, you know that I know operation, I know supply chain, I know logistics, and then he asks you, okay, what's the relationship? That's the first relationship to talk about. So operation management is the big sense. It covers all the things, include supply chain, definitely logistics. Supply chain management also cover a lot. For example, how to deal with your supplier, right? How to deal with your customers. That's the supply chain. But logistics management only focus on transportation, movement of the products. That's logistics. Okay, it's clear. So some people will get confused. What is logistics? What's the relationship logistics to supply chain operation management? That's a relationship. They're different. But again, because the subsize of supply chain expanded a lot, right, in the past 20 years. Well, the subsize is so big now, so the OM person probably they don't have enough energy to take care. That's why we need people specified in this field. The typical supply chain. So we have different suppliers, right? And it goes through the storage, and then ship to manufacturing. Okay, that's can be raw material, through the production. Okay, and store in the facility and ship to the distributor. Distributor ship to the retailer, and finally customers receive the products. If it's in the service industry, that's we also have supplier. We provide something, equipment, right? Maybe facility to provide a service. Even like you have the haircuts, right? Salon, they still have some equipment. They need a storage, right? Provide service to the customers. So it's like this is the supply chain, right? From supplier to manufacturing. Manufacturer will do the production, and through the logistics, transportation basically, right, to customers. Well, sometimes now, especially now, we have the reverse logistics, which means from customer back to the supplier, recycle, right, refurbish, something like that. Facility. Supply chain include a lot of different facilities, such as warehouse, it can be in the middle of supply chain, factory, usually is the upstream of the supply chain, processing centers, distribution center, retail outlets, and offices. Functions. There are lots of functions. Many of them we already discussed. We already studied here. Forecasting, inventory management, quantities. We'll discuss scheduling in next chapter. We haven't discussed purchasing, which is very important. Procurement. I just erased that. Information management. You have individual class on the information management, right? Production, delivery, customer service. You spend a lot of time on market class on the customer service. But some people may be curious why we already cover forecasting, like inventory management, in operation management class. Why is it also important for supply chain? What's the difference? Well, theoretically speaking, they're the same. Forecasting is forecasting. Inventory management is inventory management. But why is it important for supply chain is that all the things we discussed so far, you think about the last chapter, inventory management, we based on our information. We say, okay, we calculate our lead time, demand, then we determine the reorder points. But if we go to the supply chain, this decision shouldn't be decided individually by us. We should collaborate with our supplier, with our customers to decide our reorder point. For example, if you wait until 100 units, you place order. Well, that's my optimal reorder point. Without working with your supplier, then you have the situation. Supplier told you, okay, we just get out of stock 2 hours ago. You have to wait 1 week. That's my optimal decision. I have to order now. I need to receive 2 days later. Well, if you work with your supplier, you place order 10 hours early. You have a little bit extra inventory. You know that if you place order early, that's much better results. Right? Similar for customer, downstream, upstream. Right? Forecasting, same idea. Right? When we teach you guys forecasting, all the information based on our historical sales, something like time series model, right? Then we make a forecast. But what's happened? Okay, if your downstream know better what happened, for example, you work for Procter & Gamble, P&G, right? P&G ship your products to Walmart. Right? What you want to forecast is the order quantity from Walmart to your place, like every week. Right? That's your forecast decision. But you will have a much better idea if you know Walmart's on-hand inventory. Every second, think about that. You know that okay, if the inventory level is low, okay, you expect this week they will order more, right? They order more. If the inventory level is still very high, you know, okay, they will probably order less. Right? So you will polish or modify your forecasting results based on your data. If you collaborate with your partners in the supply chain, you will get much better results. Clear the idea? So you can do that in-house. Traditionally, people do that in-house because they have little contacts with their supply chain partner. You will only order, I receive that. There very little information sharing or collaboration happen. But nowadays, collaboration is everywhere. So that's the reason all these functions here traditionally can be an in-house job. Still, many companies just do that in-house. But it will have a much better result if you can collaborate with your partners in the supply chain to make these decisions. You will get a better result. It's very important because nowadays everybody collaborates. If you don't collaborate, your company don't collaborate in the supply chain, you can try very hard. You say Charles teach us everything. It's not enough, unfortunately. You have to collaborate. Try to collaborate. Have the information sharing, collaborate with other, much better results on forecast, inventory management, everything. Clear? See you guys on Wednesday, and I expect to see your homework.